Have you ever wondered how these super powerful AI assistants are really built? I mean, it's not magic, right? Well, today we're going to pull back the curtain and show you exactly how you can go from a messy, real world problem to a full blown, production ready AI agent. And you know what? This right here is the absolute key. Forget all the complex theory and those massive design documents you think you need. The journey to a great AI agent, it doesn't start in some sterile lab. It starts right out there in the real world with a practical and, yeah, often frustrating problem that just needs to be solved. And that's exactly where we're going to start today. All right, so for our first section, let's get our hands dirty, shall we? We're going to walk through the whole process of building our very first, and most importantly, a very useful agent. We're going to ground this whole thing in a real example that I bet you've probably run into yourself. So just imagine you're running an e-commerce store. Your support team, they're amazing, but they're spending hours every single day on the same simple requests. You know the ones: order cancellations, address changes, refund status. It's this classic case of a high-volume, low-complexity task that is just screaming for automation. Now, you might be tempted to build one giant agent that does everything, but trust me, that is a recipe for disaster. The really smart move here is to scope the problem way down. We're just going to carve off one single, manageable, solvable slice. We'll build an agent that does one thing and does it really, really well: handle order cancellations. This makes sure we build something valuable and we do it fast. So what does the logic for this thing actually look like? Well, it's a pretty simple four-step dance. First, the agent reads the email from the customer. Second, it zeroes in on that key piece of information, the order ID. Third, it calls the right tool for the job, in this case our cancel order function, and bam, step 4, it sends a nice confirmation message back to the customer. 4 clear steps. It turns a manual chore into a slick, automated workflow. Okay, so we've built a prototype, it runs, it doesn't crash. Awesome. But that is just the beginning, isn't it? The most critical question we have to ask now is this one: does it actually do the job correctly and reliably, every single time? And that question right there, that's what pivots us from just building something to engineering something that's actually trustworthy. To even begin to answer that, we've got to look under the hood. So let's take a peek inside the agent's mind and break down the core components that really make it tick. So, at the very heart of every single agent is the model. You should really think of this as the brain. This is your large language model, like a GPT-4 or a Llama 3, and it provides all the core intelligence. It's the part that reads the user's request, figures out what they actually mean, and makes the big decision about what needs to happen next. But, a brain is pretty useless if you don't have hands to act on its decisions. And that's where tools come in. For our support agent, that cancel order function, that's a tool. Tools are the specific, predefined actions an agent can take to actually interact with the world and get stuff done. And finally, we've got memory. Think of this like the agent's personal notebook. This is what lets the agent remember what's been said and done, both in the short term, within a single conversation, and in the long term, like remembering a user's preferences over time. It's what makes the whole interaction feel coherent and, well, intelligent. Okay, so now we know the fundamental parts, right? The brain, the hands, and the notebook. So let's talk about the big design decisions. These are the really crucial trade-offs that every single builder has to navigate to create an agent that's actually effective. The very first big choice is the brain itself, the model. Are you going to go with a massive, super powerful model like GPT 4.1 that can handle pretty much any complex, open-ended question you throw at it? Or do you pick a smaller, more efficient model like Phi 3 that's way faster and cheaper and perfect for well-defined tasks like our cancellation bot? It's that classic trade-off between raw power and just plain practical efficiency. And this table here, it visualizes that trade-off perfectly. Now, this MMLU score column, think of it like a report card for the model's general knowledge and problem-solving skills. Higher is usually better. So you can see Claude Opus has the highest score here, but look at the price. It's 75 times the cost of Llama 3.1. Then you have models like Phi 3, which is an open weight model. That means you can even host it yourself for maximum control and potentially lower costs, even if the performance score is a little lower. The big takeaway here is that you are always balancing power, cost, and control. And it's not just about the cost either. You're also facing this constant tug-of-war between speed and accuracy. I mean, for a self-driving car, a split-second response is everything, right? But for an agent that's analyzing legal documents, getting the answer exactly right, even if it takes a little bit longer, is totally non-negotiable. So as a developer, you have to decide which one of these is your top priority. All right, let's move on to another major fork in the road. Once you've picked your components, how do you actually arrange them? Are you going to build a single jack-of-all-trades agent, or are you going to build a specialized team of them? So a single agent system, like a simple FAQ bot, is super straightforward, and it's perfect for those narrow tasks. But for something really complex, you might want to use a multi-agent system. Imagine a cybersecurity team, right? You could have one agent that scans network logs, another one that analyzes suspicious files, and a third one that compiles a report for a human analyst. It's a really powerful way to divide and conquer complex problems, but it's also a whole lot harder to coordinate. So, we've built a prototype, we've made our key design choices, but let's be real, a prototype is not a finished product. This next part is absolutely essential. These are the practices that transform a simple proof of concept into a reliable, trustworthy system that can actually operate in the real world. You know, great agents are never built in just one shot. They evolve. The best practice is this continuous iterative loop. You build a simple version, you test it with real users, you gather that feedback, you refine it based on what you learned, and then you just repeat the cycle, making the agent smarter and more reliable with every single pass. Now, a huge part of that loop is a robust testing strategy. You need to ask yourself a few key questions. First, functional testing. Does it actually do its job? Then, boundary testing. What happens if you give it weird or unexpected inputs? You absolutely need user feedback. Are people finding it useful? Are they happy? And finally, for those really crucial tasks, you need a human in the loop, an expert who can double-check the agent's work. Just remember this, an untested agent is an untrusted agent. And this is like the final boss of testing, the real world. You can run all the simulations you want, but you will never, ever account for the messy, unpredictable nature of real users and live environments. Deploying your agent, even if it's just to a small group, is the ultimate test to see if it can truly handle the unexpected. So look, if you remember just one thing from all of this, let it be this. Building a powerful AI agent isn't about some secret magical formula. It's a disciplined engineering process. You start with a small, solvable problem, you choose the right building blocks for the job, and then you test and you test and you test again. So we know how to build a system that works. But that leaves us with maybe the most important question of all. How do we design these systems for the actual humans who are going to use them? Well, that's a topic for another day. Thanks for digging into this with me.